there is huge opportunity for AI in architecture, generally speaking, when it comes to drawing management, coordination, being smarter about optimal designs, particularly when we're working in 3D printing. I think that there's huge opportunity for anticipating errors and anomalies in the printing process, which tends to be one of the most challenging things for folks who are just getting started in 3D printing. The material itself is very finicky. It's not easy to anticipate problems. And I think that, frankly, AI can help us do that.
I'm joined by Melodie Yashar, founder of AENARA, whose work spans architecture, robotics, 3D printed housing on both Earth and space. Melodie's career has been built on the edge of what's possible in the built environment. She's gone from traditional practice in New York to NASA, then leading design at Icon. In this Buildings 2.0 episode, we discuss how designing for space reshapes how we build on Earth, why being resource constrained forces better construction thinking, the real challenges of scaling 3D printed housing beyond prototypes, and what robotics and automation could actually change in the next decade. If you care about the future of housing, construction technology, or building at a planetary scale, this episode's for you. Let's dive in. Hey everyone, thanks for listening to another episode of Buildings 2.0, a podcast that highlights the voices shaping our built environment. Today I have a really special guest, Melodie Yashar, founder of NRA. Now she's founded a new company, so she's gonna dive into what she's working on now. Her background is a space architect, technologist, researcher. The work intersects architecture, construction tech, robotics, and space exploration. I actually had the privilege of studying with her at Columbia. And so really curious before we kind of geek out about all the incredible work she's been doing, like from academic life to what she's doing now. I'm curious, like looking back, what maybe is one of the biggest either changes in like what you believe or what you see from the time we were in grad school to now?
Thank you for the introduction. It's a pleasure to be here. So from grad school to now, I would say that, well, after finishing grad school, I was working as a quote unquote terrestrial traditional architect in New York, predominantly working in this commercial sector, doing a lot of hospitality projects, things that I think are pretty typical for New York, in a lot of ground up construction, at least not for the years that I was working. Did some residential work as well, but I became very quickly disillusioned with the status and the nature of architectural coordination, with how slow things were moving, with how technology adverse the industry was, and all these cool tools and creative ideas that we had and that we had sort of developed in school to develop these really I guess you could say technology forward ways of solving spatial problems and introducing constructible solutions just were not being implemented. And I didn't see much opportunity apart from certain firms who really spearhead and champion those kinds of processes using CATIA, using these advanced software to create architecture. There wasn't a lot of room for progress, at least not in the sectors that I was working in. And I also just didn't feel like what I was contributing to was contributing to the social good. It was hard to really see how the work that I was doing was creating a real impact, and it felt extremely shallow and superficial, frankly. So, as a way of challenging myself after a couple of years of working in industry, I went back to school. I made a very, very hard pivot in my career. I studied human computer interaction and started doing research in autonomous systems. I wrote a grant while as a Carnegie Mellon, which was accepted by NASA Ames in Northern California. And that led to a full-time position working at NASA. And at that point I was like, I'm out of architecture. Like I have fully made the pivot into aerospace and I'm not going back. So I was a researcher at NASA for a number of years. And then, things kind of like in my peripheral vision, opportunities for architectural design, merging architectural design and space started to reemerge. Myself and some of our former colleagues at Columbia competed in a couple of NASA competitions for 3D printed habitats. And this, in a very organic way, launched a full on, I would say, career trajectory, thinking about large scale additive manufacturing in space, thinking about habitation in space. And the most wonderful thing was that we just started consulting, again, very organically as a result of the work that we had put out into the world. We started to receive phone calls. There was a lot of interest in the work that we were doing because it was so different and so unique. Not a lot of architects, at the time, our thinking was there's not a lot of architects working in this sector. And so that led to co-founding Space Exploration Architecture. As a result of co-founding Space Exploration Architecture, we were connected with one of our clients and collaborators at NASA Marshall, connected me to Jason Ballard at Icon, established a relationship. I became a consultant for Icon for about a year. And so I was working maybe like a year and a half as a consultant. And then after being awarded the CHAPIA proposal, which I can speak to in a little bit, I jumped ship. And he was like, "How would you like to start an architecture department within our company?" And so Icon at the time was maybe like 25 people, very, very small startup. And they had one machine that was operational in Austin. And that was just like riding a rocket ship. I moved to Austin. I was working full time at Icon for the next, I guess, 4.5 years after that. And we built a design build company, essentially. We brought aboard architects, engineers, regulatory folks, design technologists, and established a design build pipeline system of working that contributed to many, many hundreds of houses being 3D printed in the Austin area as well as elsewhere in the nation. And so, from my experience in the 3D printed habitat competition, doing some initial prototyping and large scale 3D printing, to the work that I was privileged to do at Icon, somehow I've just created this niche for myself where I can actually like work and think about like the near term applications of 3D printing and solving the global housing crisis on Earth here, and then short term, like in the here and now, but also think about the applications of the technology in the far future in space. And so I try to bridge those two worlds in my current practice. And that's a little bit about how I got to where I am now.
Oh my gosh. Okay, there's a lot to unpack there. So you took us, gosh, from school to space back down to Earth. So
Right.
in your experience, is there an idea, is there a technique that stands out to you with your work in space that has now kind of changed your thinking about how we design housing here on Earth?
It's such a good question. And there's a number of ways. It's a great question. I think that the top thing about designing for space, or the methodology that you would use for designing for space, is this notion that we need to be mindful of a resource constrained environment, right? So you don't have the opportunity to run to the hardware store or get more materials. Like, what you've got is what you got to build with. And then on top of that, you're not, at least in the work that I'm doing, thinking about robotic construction, you're not really assuming that you're going to have the support of a human crew or a contractor or somebody to fix problems. So the approach that you take is, it kind of takes, it's like sustainability on steroids. You want to be mindful of the resources that you're using. You want to be a steward to the resources that you're actually using in your project and that you're utilizing, whether they're found locally or whether you bring them from Earth. And then beyond that, it's all about building information modeling and coordination. That I feel like that is the key to a truly effective and foolproof construction operation when we're considering what happens in space. Just as in terrestrial additive manufacturing, there's like a higher degree of coordination required for the builds. It's the same thing, but maybe just 10 times more intense in space, where every activity, every task, every operation needs to be planned, coordinated ahead of time, anticipated, tested, etc. And so it forces you to think about construction on Earth in a different way. Like, if you project yourself into the future where it's going to be 10 times harder, how can we be smarter in implementing technologies, processes, checklists, etc., to be better about construction in the here and now?
Yeah, yeah. I have to imagine because, I mean, designing a space, like the threshold for avoiding failure has to be fairly high. But I have to imagine, like in the design process, like you have to do so many iterations just to like reach certain levels of threshold. I assume of safety and a bunch of other things. Are there examples like of like just ways in the design process where you guys just epically failed? Like I'm
Yeah.
a believer, like you probably learn more from the failures and the successes, but like are there times where it's just like, yeah, no, that definitely did not work?
I should say, like, in full disclosure, at Icon, we were always iterating and thinking of new ways of engineering structures, new ways of executing, let's say, construction operations or what our construction sequencing is going to be. And definitely, there are times where it's just way harder than you anticipate. And you forget about the logistics of what it means to have one of your construction operators or somebody who's monitoring the print. Working at night where there's not a lot of visibility or where if they have to be on a 12-foot ladder to do inspections. These are some of the things as a designer that, of course, like you learn by doing and you realize after the fact that these are just things that you need to be more mindful of and mitigate the risks for.
Talk to me a little bit about the overlap between your work in design, but also robotics. So that's an
Mm.
interesting intersection. And for anyone maybe listening, how have you found that merging? Like, how have you been able to marry that within your own career?
It's a difficult area. I would say that there's a lot of interest in, I would say, extending some of the current processes that we use for digital fabrication and manufacturing into the realm of robotic assembly or robotic construction. Like I think that the world of robotics right now has sort of bifurcated into two. There was a lot of interest in construction robotics in the 80s and 90s, and especially like Komatsu and other construction giants were really focused on single use task construction robotics. And now, especially with a lot of the tech companies out there today, there's this huge interest in humanoid robotics who have this like dexterous human like capability to do potentially as much as a human does. And so there's a huge divide the way that I see it in providers who are thinking about construction robots, single use task robotics, kind of like a 3D printer who can do one thing very well, as opposed to robots that can do a wide variety of tasks. So where the construction industry goes, I'm not sure. I think that for the time being, there are great companies out there like Gravis Robotics focusing on excavation, Icon in 3D printing. But if we're really invested in this vision, which I have in space of a completely autonomous construction operation being executed by multiple robots, there's going to have to be some other thinking involved for like what are the tasks needed to actually complete, finish out, pressurize, check, safety check, and inspect a structure prior to it being operational. So those are some of the things that I try to do in my research practice. Think about what are those activities, construction activities, what are those tasks, and do we have the capabilities to imagine how they might be executed in space?
Well, in your experience in housing in general, I'm curious to hear from you, like what would you define as like success? So we're generally aware that there's a housing crisis, and there's an affordability crisis. We're kind of slow to keep up with the demand. There's an aging population of construction workers that are leaving the force. In your view, like what do you define as like success? And then like through your work through robotics and processes and systems, like I assume we're going to get more efficient, but like assuming your kind of dream list is true, like what success look like for housing in say 10 years from now?
I would say that it comes down to lowering the cost of construction, the speed of construction, and achieving volume in a way that we haven't been able to before. And I think that a lot of the interest in industrialized home building has promised that, but hasn't delivered a product that is of sufficient quality to be able to introduce architectural solutions that I think are necessary for the next generation. We get cheaper products, but the quality goes down every single time. I don't think that
Yeah.
there's the kind of vision associated in the housing market with creating dignified solutions for people to live in. And so that's really the balancing act, I think, is figuring out whether there's a technology or a process or a system which can introduce a higher quality product faster and cheaper. Not an easy thing to do, right? Like that's
Right.
really the bottom line when it comes to construction.
But for those that maybe haven't been keeping up, are we still facing this like dichotomy of like, scale, but at the expense of, say, customization, right? Like there's this idea of like the Levittown where like everyone just gets the same thing, and that's one idea of scale. Are we no longer facing that dichotomy with the evolution of things like 3D printing, or is it still the same dilemma where it's like we can scale, but it needs to look like a black car and there's no other configuration? Is that no longer true?
It's such a good question. You know, the promise and the excitement of 3D printing is the versatility that you can introduce in design to manufacture a bespoke solution for a customer or homeowner or whomever. And I think that's true to a certain extent. But the reality is that 3D printing only solves, let's say, 60% of the problem. You still have to finish your home out traditionally, your plumbing, electrical happens traditionally, your roofing happens traditionally. And so, you know, the delta between the efficiencies that you introduce in 3D printing and then the time it takes to finish out the home traditionally is very significant. So to go back to your question, I think that we haven't fully realized, and Icon is really leading the way in this, but we haven't fully realized like a complete home product which introduces efficiencies all across the board, where we can safely say, hey, we can introduce a fully customized, fully bespoke solution that doesn't have an effect on your total time to construct or your total cost. Ultimately, I think like there's ramifications for both. When you have, you know, you're creating 20 bespoke or custom projects, your time and your costs go up pretty significantly.
What are some of the limiting factors? So like if you were to wave a wand and say we were to scale this process, let's use kind of Icon as an example. Like what's keeping this production process scaling across, cities at scale, perhaps not at the neighborhood level, but like cities and states? What needs to be true? Is it a cost issue? Is it a regulatory issue? I assume a little bit of everything, but what's kind of the biggest hurdles you've seen?
I would say it's predominantly a regulatory hurdle. And I would say that the cost to mobilize the technology are not insignificant either. So you really have to have an opportunity, an owner, and a construction entity who is familiar with the technology, who can really introduce an efficient proposal for deploying the technology, which again is not insignificant, who has a stable material supply chain for actually using materials that are cost effective. And then of course on the regulatory front, like 3D printing is not construction, and it is not a building system that has IBC approval. There's no IBC code for 3D printed construction just yet. And so how you actually get approvals for 3D printed buildings varies jurisdiction by jurisdiction. Personally, right now I'm working in California, and I don't think it's impossible. It's just that the level of involvement needed to actually gain approvals for this kind of construction in a jurisdiction like for us in Altadena or LA County that is for good reason skeptical, you know, of the technology and of the lack of testing and the lack of engineering data given how new it is. It just takes an extra amount of effort to really get it across the line. And what I've seen is that homeowners in certain groups, unless they really want to be a missionary for the technology and really spearhead and champion the value of the technology, it's just not something they're willing to do. They want to build more cheaply. They want to have some better guarantees that their project is going to get permitted in a shorter amount of time. And so those are some of the hurdles that we see. On top of that, like there is a significant amount of testing that's usually required for using the technology, which you don't need if you're building in stick frame or some other material. So, yeah.
You just mentioned this, but you're in California now. You're taking the culmination of your experiences in 3D printing and in space and housing and all these things, and you're making it your own. You recently founded your own thing. Talk to us. Like, what's exciting to you now? What are you working on?
Yeah, so I started my own practice towards the beginning of the year. It was something that happened very organically. One thing is that after the Altadena fires and the Palisades fires, there were a lot of folks I was speaking with who were interested in large scale additive manufacturing and felt like this was a fantastic fireproof material solution, structural solution for rebuilding in the area. And so a number of projects sort of came about as a result of those conversations very organically. And I feel really privileged to be able to contribute and rebuild in the community. Nearly everyone I know, like families, close friends, family, etc., had knows someone or was directly affected by the fires in Altadena or in the Palisades. And so, yeah, it means a lot. It's a wonderful thing to be contributing to. And then alongside that, I'm continuing doing research, thinking about construction in space, particularly autonomous construction on the surface of the moon and Mars. And so, I have a wonderful museum commission that I've been privileged to develop, and we're building a cutaway section of an entire Mars habitat that's going to be exhibited in 2026, which I'm super excited about. It's one thing just to imagine this work on paper or produce renderings or videos or something like that. And it's another to really build it at scale, and to stand by that work and to see what it actually is going to be, project yourself into the future, and ask yourself, wow, like, is this really possible? Can all of this happen using robotics, using current technologies that we have, even if we're going to project ahead into the future and assume that there's more intelligence imbued in these systems, that we have, vision systems, AI systems, etc., that can really help get us there. So, yeah, I'm sure you're no stranger to this. It's one thing to design something; it's another thing to build it at scale, and so that's what we're doing now for this piece.
One thing that also stands out to me is that in addition to your practice, in addition to your research work, you've also been a teacher, an educator.
Mm,
I'm putting myself in the shoes of, say, someone who's maybe interested in studying architecture. For me, I didn't even know space architecture was a thing.
yeah.
For those maybe listening to you and just really captivated by the idea of designing, but designing in space, where do they even start? Like, what is there even a is there a pathway to study this? Like, where should they begin?
It's such a good question. There are wonderful resources available online, particularly AIAA's Space Architecture Technical Committee. It's a professional organization association of space architects under AIAA, the American Institute of Aeronautics Astronautics. They have a wonderful website called spacearchitect.org with a bunch of resources on like where to get started, educational programs that are available. Of course, you and I went to Columbia, like, I didn't go through those educational programs. This was really something that I learned on the fly, but, there's wonderful resources available out there ranging from videos, lectures, to full-on accredited academic programs. In addition to that, like, the truth is that it's still an emerging area. It's not like there's, how can I say it? There's not a confirmed pedagogy for how to teach space architecture. It's an evolving discipline. The idea of a space architect is still a kind of a new concept in aerospace engineering. I wouldn't say that every aerospace company necessarily subscribes to the notion of having a space architect on board. It feels a little bit too early. And yet, like the space architecture concepts that I've been privileged to contribute to have been so foundational to thinking about what the future should be in space and what kinds of research activities we should be prioritizing in our work in the here and now. So it always feeds back, it always comes back around to informing technology development, informing how funding for research and development is actually. I can personally testify to this, like that the space architecture work we developed at ICON had a direct impact on the funding and the vision that we were able to attribute for some of the technologies that were developed in house. And it also is just an inspiring way to think about what might be possible, like why can't we do this? What's stopping us from doing this? So it's one way of thinking optimistically about the future and projecting us to a place that we would like to be.
Yeah. On the future, 10 years out, 15 years out, 20 years out, you're one of the few folks, at the front lines of this. In terms of timeline, will we see habitats on Mars, at least in our timeline? Or are we significantly far away from just like what needs to be true in order for us to get there?
There's a lot that does need to happen before we can safely send humans to Mars. I do believe that it will happen. in our lifetime. So for the current project that I'm contributing to in AENARA for our Mars that has a Mars scope and that would be built on Mars, we're imagining no earlier than 2075 for like the first crewed mission to Mars. I think that there are other groups, particularly private aerospace companies, that are more aspirational and would vouch for earlier numbers and closer dates. But that's the comfortable place where I'm at is like 50 years into the future. I really believe that we'll see development on the moon, in situ resource utilization, surface development, infrastructure development in the next couple of years, like 10 years, the next decade. And I do see the moon as a stepping stone prior to all of the technologies and activities that we're going to be engaged in on the surface of Mars. So yeah, I think one will happen before the other, but inevitably, I do believe we will get to Mars.
Yeah. You've mentioned robotics, 3D printing. It wouldn't be a technology podcast if I didn't ask, but AI.
Yeah.
What is the role of maybe AI relative to, these design intersections? Does it maybe speed up the timeline or not really? What's the role of AI relative to what you're designing?
I think that there is huge opportunity for AI in architecture, generally speaking, when it comes to drawing management, coordination, being smarter about optimal designs, particularly when we're working in 3D printing. I think that there's huge opportunity for anticipating errors and anomalies in the printing process, which tends to be one of the most challenging things for folks who are just getting started in 3D printing. The material itself is very finicky. It's not easy to anticipate problems. And I think that, frankly, AI can help us do that. Yeah. So the truth is that the delta, though, again, between design and construction is so great. I think that the biggest hurdle for really getting other trades, vendors, etc., to work at the speed of what additive manufacturing and other, frankly, robotic assembly methods can provide is just so great. And so, how we do that is something that we're going to have to keep working on and thinking of solutions towards in the future.
For maybe future melodies just coming up, maybe from their studies or just joining, starting their career. Are there maybe one or two principles or a list of principles that in your career you've come to believe specifically about your work in housing that
Mhm.
you would leave behind for someone just starting? Something that you wish you knew starting out? I'm curious.
Think that well, there's two things. First is follow your passion. If your gut is telling you like this is not aligned with what you're interested in, I would pay attention to that because there's probably a better and more, let's say, lucrative way of solving a problem relative to housing than what it is that you're engaged in. I think that there's so many parts to the problem ranging from permitting. I think like the idea of pre-permitted plans is a fantastic thing, which has contributed to large volume housing being introduced historically in Chicago, for example. And so, why we're not working towards that for other cities and jurisdictions, that's a huge question. But beyond that, I think sometimes when we're working in firms, what I experienced at least is that like there's this aversion to introducing new tools and technologies that could potentially change the way we work and the way that we think about design. And so I'm an advocate for experimentation. I'm an advocate for thinking about new ways of doing things. For us at Icon, for example, a lot of that had to do with systems that we would come up with essentially for coordinating 3D printing with other disciplines, which was not something straightforward, not something obvious. And then coming up with easy, seamless, efficient ways of optimizing our construction operations so that like as soon as we have a model built, we can procure the rebar necessary, procure the materials necessary. And that was a really, like seamless way of going from design into construction. So, yeah, I'm an advocate for following your passion and coming up with new tools and processes to really help improve what we're doing.
Yeah. This has been so fun. You've taken us on a journey here from your own personal career, but also we can't help but to root for you. I mean, I think the problems you are working on are hard and meaningful. And so I just, for anyone listening, how do they follow you? How, if there's any interest in working with you in the future, where should they be looking?
Yeah, you can check us out. You can check out AENARA at AENARA.space, AENARA.space, or reach out to me directly via LinkedIn, social media. Everything is my name, Melodie Yashar. And thank you, Jose. This was a lot of fun. I'm glad we were able to do this.
Thanks so much.